Unit 6, Lesson 4, Angles of Elevation and Depression. Your objective for this lesson is to use angles of elevation and depression to solve problems. This is what we're looking at in Lesson 3 basically, but with word problems. Okay, so let's start off with defining what angle of elevation and angle of depression are. An angle of elevation, you can see a picture here, is an angle between an observer's line of sight. So you can see this little stick figure, her eyes are looking right out that way. And, or the line of sight is this diagonal line, and a horizontal line. And this is for when the observer is looking up. So elevation, you could think an elevator brings you up. Angle of depression. So this is the same thing except when the observer is looking down. So down depression. Example 1. The angle of elevation from point A to the top of a cliff is 34 degrees. If point A is 1,000 feet from the base of the cliff, how high is the cliff? I'm going to start off by drawing a picture. You're not always going to have a picture given to you here, so I thought we could draw this picture together. So here's my triangle. And it is an angle of elevation, so my person is looking up, or it's really just, up. And the angle on the bottom is 34 degrees. So when you have an angle of elevation, you have a right triangle, and the angle on the bottom is your angle of elevation. And we have point A. Well, here's our cliff, I guess. It's not a good cliff. Point A is 1,000 feet from the point of the cliff. How high is the cliff? So basically over here, this is X. Or you could call it H for height if you wanted to. C for cliff. Okay, so how high is the cliff? Well, fortunately, I have some trigonometry up my sleeve now that I can throw at this problem. I have 34 degrees here. That's my angle. So in terms of this angle, looking out, X is opposite. 1,000 is adjacent. And this side, without anything labeled, is the hypotenuse. And I'm going to write SOHCAHTOA. And since we don't have anything at all written for hypotenuse, we're going to cross that out, the H's over here. So we're going to use tangent here because I'm looking for opposite. So this is what I'm looking for. And I have adjacent. Okay, so I can say tangent of my angle, so of 34 degrees, equals opposite is X divided by 1,000. Okay, and I want to get X by itself. So I like to do this by getting X by itself first. You might want to find tan and then get X by itself, but I'm going to get X by itself. To do that, I need to multiply both sides by 1,000. Okay, because this is division. You undo division with multiplication. So I have 1,000 times tan of 34 degrees is equal to X. Now I'm going to pull out my calculator because I don't know what tan 34 degrees is off the top of my head. I'm going to make sure that I'm in degree mode because I'm using degrees, and I am. And then I'm going to type in 1,000 times tan 34, close parentheses. Enter. And I get 674.5. So that's what I'm going to write. This is, and it doesn't specify how many decimal places here, so I'm just going to write that down. 674.5 feet. That is how tall this cliff is. Okay, example 2. To estimate the height of a garage, Jason sights the top of the garage at a 42-degree angle of elevation. So I'm going to stop right there and I'm going to draw a picture of that. Because I think the problem's about to get a little bit more complicated. So let me do this one the other way. Okay. So Jason has a 42-degree angle of elevation. So that's down here. And he's right here. So this is the top of the garage. I'll just write garage. Okay. He then steps back 20 feet and sights the top at, I think I wrote that wrong, and sights the top at a 10-degree angle. So he moved back and is now seeing a 10-degree angle of elevation. Okay, so that means right here, this is 20 feet from where he was then to where he is now. And that is 10 degrees. If Jason is 6 feet tall, how tall is the garage to the nearest foot? So here's Jason, I'm gonna put a J, and he is 6 feet tall. So this whole thing is the garage. Okay, and this is a right angle. Okay, so we have 2 unknown lengths here that we need in order to solve this problem. We're looking ultimately for the height of the garage, and we need to know this portion here. So I'm going to call that X. And we also don't know how far away Jason was when he first measured that 42-degree angle. Now I'm going to cover up over here, smoke screen. Okay, if I just have this triangle right here, I have my 42-degree angle, and I know that X is the opposite side and Y is the adjacent. And looking at what that gives me, SOHCAHTOA, I can't use anything with the hypotenuse because I don't have any information about the hypotenuse. So I can use tangent, and I can say tan of 42 degrees equals X divided by Y. Okay, I'm going to move that smoke screen. Now, the X is still opposite for 10, so it's still across from it. And 20 plus Y is the adjacent side of my 10-degree angle. So I can use tangent again. Tan of 10 degrees equals X divided by 20 plus Y. So I have those 2 equations that I can set up. And now we need to do a little bit of manipulative mathematics, which I know is your favorite thing to do. What I see, what do they have in common? They both have this X on top. So just like I did in this example, I can get X by itself without knowing what Y is. So let me do that. I'm going to multiply on this one. We'll do this one first. I'm going to multiply both sides by Y, and that'll cancel that out and leave me with X by itself. So I have Y times tan 42 degrees equals X. And over here, I need to multiply by 20 plus Y. those cancel. So I have 20 plus y times tan of 10 degrees equals x. Okay, we're getting a lot closer now. So I have x and x, two different things that x equals. What can I do now? Well, I could set those two things equal to each other because they're both the same thing. So I can say y tan 42 degrees equals 20 plus y times tan of 10 degrees. Since I only have one variable now, I can actually solve for y, which is useful to me. So we have to try to get y by itself though. So I'm going to distribute this tan into my parentheses. And I get 20 times tan 10 degrees equals, not equals, sorry, plus y times tan 10 degrees equals y tan 42. Okay. Now these both have a y in them. So I'm going to move this guy to the other side. I want all my y's on the same side. So I'm going to subtract. So we have y tan 42 degrees minus y tan 10 degrees equals 20 tan 10 degrees. And you'll notice that these both have a y in common. That's why we moved that one in the first place. I'm going to factor out that y, which leaves me with just tan 42 degrees minus tan 10 degrees. To get y by itself, I need to divide by this part. So tan 42 degrees minus tan 10 degrees on both sides. Okay. And that all canceled. So this portion will give me what y is approximately equal to. I'm going to go ahead and type that into my graphing calculator. Okay, so on top we have 20 tan 10 degrees. Make sure you close the parentheses. Divide by tan 42 degrees minus tan 10 degrees. And I get y is approximately 4.87. You do want to hold on to a few decimal points here. If you want to put a few more so your answer is more accurate, that is beautiful. Okay. Now, we didn't want to find y, though. We want to find the height of the garage. We just have y. So this is 4.87 approximately. But I do know from before that tan 42 is x over y, or I could say y times tan 42 is x. So let's do that. So we had y times tan 42 degrees equals x. There's, again, two ways we could do this. We could do this with our rounded answer, or we could do it this way. So that's y. So I'm going to say second answer, that was my answer, times tan 42 degrees. And I get x is 4.39 approximately, rounding to two decimal places. So x is approximately 4.39, is what we just said. Right. Yes. Okay. The other thing you could have done here is said 4.87, which is what we got. Oh gosh. 4.87 times tan 42. And you would have gotten almost the same answer. It would have rounded to 3.8 instead of 3.9. So 4.39 is the height from our man Jason's eyes to the top of the garage, but he's 6 feet tall, so that's X. 4.39 from there to there. But he's 6 feet tall, so we have to add those together. So I'm going to say 6 plus 4.39 is 10.39. So this garage to the nearest foot is 10 feet tall. Okay, so that was a long problem. It was a little bit difficult, but that gives you an idea of the extent of what you can do with trigonometry, angles of elevation, angles of depression. So, yes, that wraps up lesson 4 for us.